All right, so I'm going to go over problems from this first review. All right, so the thing you got to be careful about is now we have exponentials and logs intermingled. All right, so it's got to make sure that we're using the right basic shape, we're using the right points. Okay, so with number one, all right, we have a log graph. All right, let me zoom in here just a little bit more. That's better. All right, so with a log graph, all right, remember log graphs are the ones with vertical asymptote, and it looks like that. All right, our points that we are going to use, we use 1, 0, and we start off with 1, 0, and then 1, whatever the base is, comma 1. So in this case, it's a natural log, so it's e comma 1. Those are the points that we start off with, right? Now, the transformations that we have going on here, we have this negative here, which means we have a vertical flip. This negative in front of this x means we have a horizontal flip. All right, and then numbers in here moves, we have a horizontal slide. So we set that equal to 0, and we get a positive 3. So we're going to move to the right 3. All right, so those are the things that are happening here. Now, I always like to graph the asymptote first. Remember, with logs, the asymptote is determined by what's going on in here. Normally it's 0. We're going to slide it to the right 3. So now I'm at x equals 3. All right, since there is a horizontal flip, normally on this side, it means they're going to be on this side of the vertical asymptote. Okay, now our first point, 1, 0. All right, I'm going to start at 1, 0. And then I am going to do a vertical flip. Well, nothing changes with the vertical flip if you're on the x-axis, because a vertical flip means you change the coordinate of the y. So you change the coordinate to 0, it's still 0. Change the sign, so it's 1, 0, still 1, 0. But when I do a horizontal flip, you change the sign of x, so I go to negative 1, 0. All right, and then I move to the right 3, which means I end up at 2, 0. So I am right here, 2, 0. All right. For e, 1, all right, e is, roughly here 2.718. When I do let me just put a 1 right there. All right, and just do this. Okay, so I'm at e, 1, so I'm like right here. Then I do a vertical flip. I go to e, negative 1. All right, put the negative 1 down here just so you can see. All right, I'm down here. Then I do a horizontal flip. I go to negative e, negative 1. So when you have a vertical and horizontal flip, you change both sides here. So I'm at negative e, negative 1, and then I have to add 3, which puts me, so if it's at negative 2.78, adding 3 puts me on the positive side. All right, right around in here. Like I said, it doesn't have to be close to being exact. The most important thing is that you label the 2 points. All right, so I have a point of 2, 0. And this one here, what did I do to the x coordinate? Well, I changed the sign of it, which is negative e, then I added 3 to it. So it's negative e plus 3, and then I get a negative 1. All right, those are my 2 points for all these. Okay, now, not a spot here for domain and range. All right, but we'll just put it in here. The domain, well, which one is negative infinity to infinity? Well, it's a log, so that's the range. All right, negative infinity to infinity. The domain with a log graph is either negative infinity to the vertical asymptote or vertical asymptote to infinity. In this case, it is negative infinity to the vertical asymptote, which is at 3. All right, so there's number 1. All right, number 2. Number 2, we have a exponential. I know it's an exponential because I see it a variable in the exponent. Okay, so exponentials have a horizontal asymptote and they look like that. They have points that are, instead of 1, 0, it's 0, 1. And instead of E1, it's 1 comma the base. In this case, it's E. All right, 0. I don't know why that says 0, 1. This would be 0, 1. I think it just, all right, that's 0, 1. All right, so 0, 1 and 1 comma E. All right, so what's happening in our graph? Well, we have a negative with the x, which means we have a horizontal flip, and we are moving down 2. Now, since exponentials normally have a horizontal exponent. This is what determines our new asymptote. So we are going to be at -2, just like that. Okay. Whoops. All right. So now let's take our points 0, 1. I'm normally right here. All right. If I were to flip that horizontally, guess what? I'm still at 0, 1. I just move it down 2. So horizontal flip doesn't move the point, move it down 2. All right. 1 comma E is here. When I do a horizontal flip with that one, all right, horizontal flip, I flip over this axis. All right. I am now at -1e, change the sign of the x coordinate. I'm at -1e, and then I move down 2, all right, which is right about in there. All right, so normally the graph looks like this, horizontal flip. Now the graph is going, that's awful, not really hitting the dots, but there we go. So my points are at 0, -1. And then for the E1, you had, what did you do to it? It was at 1e, you change the sign to -1e, and then subtract 2. So it's at -1, comma, e minus 2. All right, that's that point right there. For exponentials, the domain is what's -infinity to infinity. The range is either -infinity to the horizontal asymptote if it's below. If it's above like it is here, it's the horizontal asymptote to infinity, which means the horizontal asymptote is at -2, so it's -2 to infinity. All right. Now, number 3. Told you guys, hopefully you guys saw this. This is something we call like a stretch. We're not doing those when we have a constant out front. So we're going to pretend that's not there right now. We are just doing this. Now, is this an exponential or is this a log? Well, it's an exponential variable up here in the exponent. It's not a log. All right. So my points are going to be 0, 1, and you are going to have 1 comma the base, which in this case is 1/2. So when I have one like this, instead of using 1/2, I like to use, I like to use -1, and then I get 2. All right, because that's the one that basic shape looks like this. All right, that's what I like to do. All right, now what's going on in our graph? Well, we have a horizontal flip, and we have a shift horizontal slide, and it's 1, and we're going to move 1 to the right. All right, sorry, something happened there. You saw I got wiped. I lost connection. I lost these 2 things here, but it should still be on the video. Okay, so I think this is where we left off, right? We have 0, 1 as our point because it's an exponential. And I said -1 comma 2 because this is 1/2 instead of 1 comma half because it's going to look something like that. All right, so we are going to have our horizontal asymptote. There's no number over here, so it's going to stay at 0. All right, it's going to stay at 0. All right, let's just put a couple things here. Okay. Now for our points, all right, we start at 0, 1. Doing a horizontal flip means I change the axis. It stays there, but I move it 1 to the right. So it goes right there. -1, 2, if I get a horizontal flip, it goes to this side, but then I move that to the, so I'm at 1, sorry, so I was at -1, 2. I flip it, I go to 1 comma 2, and then 1 to the right puts me at 2 comma 1. Looks just like that. All right. So that's 2 comma 2 and 1 comma 1. All right. Now, since this is a log graph, all right, since it's a log graph, the domain of this is going to be -infinity to infinity. And the range, since it's above, is going to be from the horizontal asymptote, which in this case is 0 to infinity. All right, 0 to infinity. All right, so number 4. Number 4, we have a log graph. All right, so our points, log base 2. So it's going to be 1 comma 0, and we are going to do the base comma 1. So it's 2 comma 1. All right, instead of 1 comma the base, it's the base comma 1. All right, now the only thing that's going on here is this. The only thing we have going on is a vertical flip, nothing else. So we will still have a vertical asymptote. all right, we will still have a vertical asymptote at 0. All right. So to do 1, 0, a vertical flip means that you change the y coordinate. Well, guess what? It just stays there. Nothing happens at that point. 2, 1, I'm at right here, just means I change the sign of the y, flip it, becomes 2, -1. And looks just like that. All right, so this is 1, 0, and 2, -1. Make sure you label the 2 points. All right, I need 2 points. Okay. Now, I know this direction says 1 point. We've been doing 2. I'm not quite sure why that says 2. When you get to calculus, and if you guys have me in accelerated calc, you only have to do 1. But you got to do 2 right now. All right. Now, for number 5. This isn't one of the ones, but we're going to get rid of this guy. All right, so this is an exponential, back to an exponential. So we just have to keep straight. This is the one with the horizontal asymptote. This is the kind where I have 0, 1, and then I have 1, the base, which in this case, the base is 3. So those are the points I'm going to start with. The only thing I have going on in this problem. Now, as I erased this, I told, depends. If you, hopefully, I wanted you just to get rid of the 2. Let's keep the negative there. All right. If you got rid of the negative 2, you'll see where your problem just, it affects it a little bit. So if we keep the negative as a vertical flip, if you get rid of the negative, obviously it doesn't. And then it moves 2 to the right because we set this equal to 0. All right. So nothing is over here. So the horizontal asymptote stays at 0. All right. Okay. Now, if you have the negative up front, that means you do a vertical flip. 0, 1 means you change the sign of the y. I go to 0, -1, and then to the 2 right. So it's right there at 2, -1. 1, 3, which is right here, I do a vertical flip. It goes to 1, -3, and then 2 to the right. And that point is at 3, -3. And the graph looks like that. So this is at 3, -3, and that's at, what is that, 2, -1, I believe. Yeah, 2, -1. Now, if you didn't do a vertical flip, you would just moved it 2 to the right. That'd be 2, 1, and it would be at 3, 3, going like that. So if you did that, that's okay. Just make sure you understand what happens if a negative goes in there. So domain is always for an exponential, -infinity to infinity. Put the parentheses in there. The range it's below right now, so it's -infinity to the horizontal asymptote, which was at 0. All right, moving along. All right. Nice little hole right there, huh? Okay. So we're back to an exponential again. All right. So we have base e. So it's going to be 0, 1. All right. And then 1, e. All right. Now we have 2 things going on here. We have a negative in front of the x. So we have a horizontal flip. And we have a horizontal slide. So we set that equal to 0. It's not 2 that sets that equal to 0. It's -2, which means we're moving 2 to the left. All right, it's 2 to the left. No vertical slide, so it means we're going to keep it at 0 for our horizontal asymptote. All right, just put that up there a little bit. All right, put some numbers over here. Okay, so our first point, 0, 1, horizontal flip. Horizontal flip means I change the sign of the x. Well, guess what? It stays exactly where it is, but it moves 2 to the left. So it's going to be at -2, 1. 1, e is right around here. Horizontal flip moves it to -1, e. A 2 to the left puts it at -3, e. All right, so it looks something like that. All right, so this point right here, that was what? -2, 1. This point is -e, -3. All right, because we changed. Wait, hold on. That's the opposite of what I meant to say. Got a little dyslexic there for a second. I apologize. All right, it's -3 because negative 3 e. All right, it's negative 3e because nothing happens to the y. It's just x's we were changing. Horizontal flip and 2 to the left just affects the x's. All right, so vertical flips affect the y. Horizontal flips affect the x. Obviously, moving to left or right affects the x. Moving up or down affects the y. All right, so this was just everything affecting the x. Notice why the y coordinates did not change at all. All right. Switching gears here to a log with a base 3. So now it's 1 comma 0 and the base, which is 3 comma 1. All right, 1 comma 0 and 3 comma 1. All right, are our points. A lot going on here. We have a switch things here. We have a vertical flip because we got this negative out in front. We have a horizontal slide of 3 to the left. We're going to move because negative 3 makes us equal 0, and we're going to move up 1. All right, so this affects the y, this affects the y, this affects the x. All right, since it's a log, this is what is the asymptote. Vertical asymptote is 3 to the left, so it's going to be at negative 3 is where I'm going to have my vertical asymptote in this particular problem. Okay, so I'm going to put it as, what is it, negative 3? All right, negative 3 right there is going to be our vertical asymptote. Okay, so we'll start off at 1 comma 0. All right, so we're at 1 comma 0. So if I'm at 1, 0, which is over here, I am then going to do a vertical flip. Vertical flip affects the y, which means nothing changes. I'm going to move. Now, the order here of the slides doesn't matter. I move 3 to the left, 1, 2, 3, up 1. Or I can move up 1 to the left 3. Those don't matter. What matters is you have to do a flip before the slide. All right, you have to do a flip before the slide. All right. So now with 3 comma 1, which is here, a vertical flip puts it at 3 negative 1. I move it to the left. It's at 0 negative 1, and then move it up 1. I am at the origin, and the graph looks like that. So I am at 0 comma 0, and I am at negative 2 comma 1. Now I forgot to, as I'm looking at this, forgot to do the domain and range of this guy, which this is the domain here is negative infinity to infinity, where in a log graph, the range is what is negative infinity to infinity. Here, the range is going to be the horizontal asymptote, which is 0 to infinity. Here, it's going to be our vertical asymptote, which is negative 3 to infinity. All right. So now, number 8. All right, number 8, we have another log graph. Now, there is no base here. What does that mean? It's a base 10 guy. All right, we have a base 10. All right, so base 10 means that we start off with 1 comma 0. And we start off with 10 comma 1. Okay. Now, no negative in front, so that's a vertical flip. Negative here, that is a horizontal flip. Set this equal to 0. We have a horizontal slide. That's going to be what? Negative 3. So that's going to be 3 to the left. And then we're going to go down 1. All right, negative 1. So our asymptote, all right, is normally at 0. We are going to move it over to 3. All right. And I'm not putting slash marks for log base 10 because so x equals negative 3. I'm just labeling that because you'll have a lot of slash marks if you do that for a log base 10 graph. Okay. So we're at 1, 0. So what's happening here? Horizontal flip affects the sign of the x's. Moving 3 to the left affects the x. Down 1 affects the y. All right. So if I'm at 1 comma 0, and if I do a horizontal flip, that means it becomes negative 1 comma 0. And then I move it to the left 3, negative 1, that'd be negative 4. And then I move it down 1, puts it right here at negative 4. I just want to label it now before I forget. It's negative 4, negative 1. Because I change the sign to make it negative 1. I subtracted 3, becomes negative 4. I add 1 to the y. That's where you get negative 4, negative 1. All right, 10, 1. I do a horizontal flip, it becomes negative 10, 1. All right, and then move it even further over, it's negative 13, comma 1, and then down 1, I am here, and kind of going into the other graph, but that is negative 13 comma 0. You can see why I don't want to write 13 slash mark. So that's a negative 13 right there, comma 0. So negative 13 comma 0, negative 4, negative 1. The reason I got negative 13 comma 0 started with 10, 1, right? Horizontal flip means I flip over the y-axis. Well, that just changes the sign. That's negative 10. I then move 3 to the left, which means I subtract 3. Negative 10 minus 3 is negative 13. I'm at 1. Subtract 1 from the y because that's down 1 means that's where I get negative 13, 0. So you can just do the operations if you want. You can, if you're more visual, any way that you get these 2 points is good with me. All right, now 9, that 2 we didn't want to deal with, but we are going to deal with the negative. Once again, just like number 5, if you got rid of that negative 2, no big deal. So natural log, this is another log graph. So this is 1, 0, and the base, which is e, comma 1. And we have 2 flips here. We have a negative out front, so we have a vertical flip and a horizontal flip. These are great because the only thing that happens is you're going to change the signs of both. That's your new point. Those are your new points. All right. Didn't slide at all. So I'm going to be here. All right. So for my 2 points, I'm normally at 1, 0. Change the sign of both of those. Can't change the sign of 0. I'm at negative 1, 0. All right. E, comma 1 is really negative e, comma negative 1. All right. Started here, you flip it down this way, flip it there, it comes there. Just change the sign of both the x and the y if you're doing a flip for both. Negative 1, 0, negative e, negative 1. And once again, I forgot to do the domain and range of the last 2. So doing number 9 first. Well, they're both log graphs, right? So that means the range is what is negative infinity to infinity. The domain, these are both on the left-hand side, so it's going to be negative infinity to whatever the horizontal asymptote is. Whoops, sorry. To negative 3. That was supposed to be a comma. Going a little out of control here. And then this one is negative infinity to vertical asymptote 0. All right. Now, last one. All right. We have an exponential. All right. We have the exponential, and we have, so 1 comma 0. Whoops, lied. 0 comma 1. And the base comma, which is 4/3, the base comma 1. All right. So it's going to be 4/3 was over 1. So it's still a growth function. It's not a decay. So that's why I didn't use negative 1 in there. I still want it going this way. All right. So I have a vertical flip, which means you change the signs of the y's, and we're going to go up 4. So the x's, nothing is happening to the x's. There's no horizontal flip, which means you don't change the sign. There's no slide, so it means we're not adding or subtracting anything. All right. So this right here is my horizontal asymptote. Right there. And since it's a vertical flip, we're now going to be on the bottom half of this guy. All right. So normally I am at 0 comma 1. If I do a vertical flip, all right, if I do a vertical flip, that means I go to 0, negative 1, but then I'm going to move up 4, which puts me right here at 0 comma 3. All right. 0 comma 3. That's awful. I can't read any of that. Here, I'll write that point at the end. All right. And then this point, 4/3 comma 1. All right. The 1 is going to end up being the same because nothing's happened to y, but 4/3 is 1 1/3 comma 1. If I do a vertical flip, all right, I'm now going to be at negative 4/3, right? Then I have to add negative 4/3. So I'm sorry. Say this again. 4/3 comma 1. A vertical flip puts me at 4/3 comma negative 1. Wait, what am I talking about? Sorry for confusing us. You guys hopefully were saying, like, Mr. Gunn, what are you doing for this problem? This should have been 1 comma the base, which is 1 comma 4/3, because we're doing an exponential. But I realized I was wrong as I was going through this graph. And that's, if you do have to make a mistake, you'll quickly realize this shape does not look what it should. All right. If I was being really smart, I would say I did that on purpose, but I did not. All right. So 1 comma 4/3. So 1 comma 4/3 is right in here. I flip it, which is 1 negative 4/3. Then I add 4. So negative 4/3 plus 4/3 thirds, that's 12, 8 thirds, which is still less than 3. So it's like right there. All right. And this is where the naming of the points, the labeling is very important. All right. So we end up with 0, 3. All right. And then here we end up with 1, 8 thirds. Now, just look what happened. We had 4 thirds. All right. That's our y coordinate. Vertical flip means you change the sign, so that becomes negative 4 thirds. This plus 4 means we add 4 to the y coordinate. So if you add 4 to that, what we just did is we just basically did negative 4 thirds plus 12 thirds and gave me 8 thirds. And that's where I get my new y coordinate. 1 didn't change. It originally started at 1 because there's nothing happening to the x here. We started with 0, 1. We changed the sign of the y. It's negative 1. We add 4 to it. That's where we get the 3. All right. Hopefully you guys were okay with these graphs. If not, reach out with any questions. There will be more practice tomorrow or the next time we meet for another review before your quiz first time we meet next week. Okay. Now, this was a little bit different. All right. This was a little bit different. This is where I'm giving you the graph. You have to come up with the function, the equation. Okay. Now, first thing you should recognize first is, are we dealing with a log graph or are we dealing with an exponential? All right. So we know log graphs. All right. Remember, log graphs have a vertical asymptote and go like this. Exponentials have horizontals and have the basic shape of that. So by looking at this, you should be able to determine that this one right here is some sort of log. This is some sort of exponential. And this one is also an exponential. All right. So the other thing is, once you've done that, so we're looking at this one, we know we have a log. Well, first of all, make sure it is y equals, that you write it as a function. All right. I will take off if you do not write it as a function. All right. So the next thing I would look for is, do you see an e in here anywhere? No. What does that tell me? It tells me there's no natural log, So this is a log. All right. So I know I have a log base something. All right. Now, the basic shape of a log is this, right? If there was a vertical flip, it then looks like that. If there is a horizontal flip, it then would be on the other side of the axis. So since it's on the right side here, right, of the asymptote, that means that there is no horizontal flip. Since it looks like its original shape, there is no vertical flip, which means there's no negative in front and there's no negative in front of the x. All right. All right. So there's no negative in front of the x. Now, in terms of slides, right? In terms of slides. Now, notice the vertical asymptote is still at 0, which means I didn't slide it left or right, which means it's log base something of x. It didn't get slided at all. Because if this were to be somewhere else, that means it would have a different, you would have x, like for instance, say this was at 1. That means x minus 1 would have to be here because we had a shift of 1 to the right. If it was at negative 2, that means we would have an x plus 2 in here. So the thing you have to remember is, normally I'm at 1, 0. What happened to get this other point? I moved it down 3. Normally, right? I moved 1, 0. I moved it down 3. So what does that tell me? That tells me that I moved down 3. The other question is, what's my base? Well, the second point is always your base, comma, 1, right? Well, we saw we moved it down 3 and negative 1. Well, what's my x-coordinate? 3, which means it's log base 3. If this was 2, negative 2, it'd be a base 2. So for this one, it's log base 3 of x minus 3, right? Because normally you have 1, 0, and you're at the base, comma, 1. Well, what happened? I just moved this down 3. All right, this one moved down 3 as well, but since this x-coordinate's 3, that tells me what our base is. If this was 4, negative 2, that means it'd be log base 4. All right, let's see if we look at 12. All right, 12, like I said before, is an exponential. Also, we notice that there's some e's in here, which means we're going to have, it's going to be y equals something with an e in it. All right, now, the basic shape of a exponential is this. This is the exact shape. There is no flips going on here. All right, this is the shape, which means there's no negative in front and there's no negative with the x. All right, so it's just x something. Okay, our normal point is 0, 1, and it'd be 1 comma e, right? That's our normal, that would be our basic shape. Well, what's happening? What did I do here? Well, I moved it to the left 2. What happened here? Moved it to the left 2. This was at 1, becomes negative 1. So the only thing is I'm moving to the left 2. It didn't move up and down at all. See how my asymptote's at 0? That means there's nothing out here. So how do I represent a slide of 2 to the left? X plus 2. There you go. Y equals e to the x plus 2. Then you can go back and graph it and see if it works. Okay. Now, 13, last one, is also an exponential. But there's no e in it, so we're not going to have e. So we're going to figure out what the base is. Okay. But we'll worry about that in a second. The first thing that you should notice is this is on the bottom of the asymptote. All right. So that negative needs to go there. It's a vertical flip. So that negative needs to happen. All right. So in pink here, I'm going to start. All basic shapes of an exponential go with 0, 1. So I know there has to be a vertical flip, which means I'm going to go to 0, -1. But for me to start and go right back up there, what happened? That means that I added 2 to it to get back up there. So I need a plus 2. All right. And how do I also know that there has to be a plus 2? Where's my horizontal asymptote? It's at 2. So both of those things fit. Notice, did anything slide to the right or left? No. All right. So whatever my base is, there is no slide to the right and left. Now, normally it's 1 comma the base, right? It's 1 comma the base. So if it was base 3, it'd be 1 comma 3. If I did a vertical flip, it's 1, -3. Adding 2 only gets me to -1. So if I was at 2, though, if it was base 2, 2 comma 1, 1 comma 2 be here. I do a vertical flip down to -2, add 1, that's exactly where it would end. So my base is 2. So it's -2 to the x plus 2. I tell this 2 because of the horizontal asymptote. All right. I knew it was negative here because it was underneath the horizontal asymptote. Then you know there's no slide because 0, 1, if I flip it, it goes here, comes back up 2. There's no other slide. The key is figuring out what the base is. So you might have to do a guess and check. I would always guess with 2 first. If 2 didn't work, I would see if 3 would work. So you would start with your point, do the transformations you know are happening to figure out what the base is. All right. So these are a little challenging. They're meant to be a little more challenging. But this is an honors course. So hopefully by the end here, you start to pick up on a few. If you have any questions, just let me know. Like I said, there will be another review worksheet next class. All right. Hope everyone's staying safe and healthy, and talk to you guys soon.